Hi everyone, so this is going to be our last section for our Jovian planets note. I did want to talk a little bit about Pluto because it was a pretty significant memory or idea that we heard about a lot when we were younger. So again, looking at our average distance from our sun, we have 5.91 times 10 to the 9th kilometers. So writing it all the way out, again, very, very large distance away from the sun at this point. Our orbital period here as well is going to be 248.6 years. So in 1 year on Pluto, it is 248.6 years on Earth. So that's our big difference here. And then again, looking at some average temperatures over here, negative 387 degrees Fahrenheit. Very, very cold on our planet Pluto here. So Pluto was discovered as it moved in the background of our stars. So Pluto's moon Charon was originally thought to be deflected images of Pluto. So we discovered Pluto by seeing it move in our stars rather than it stay constant like our stars do. So Pluto and its moon Charon are about the same size, and they are locked in a mutual synchronous orbit. So they move together, which makes it kind of difficult to see both of them sometimes. So they always face each other as well. So you can see these two, Pluto and its moon here, in a synchronous orbit. Two more moons over here are Nix and Hydra. So these are two more moons for our dwarf planet Pluto. So looking at a comparison between all of our outer planets, or Jovian planets, Jupiter has a terrestrial core, but again is still a gas planet here. We see Saturn very similar to Jupiter with less metallic hydrogen that we pointed out. Uranus, again, very, very similar to Neptune here, with that liquid water shell and our liquid hydrogen helium mantle here. Something really unique to note here, that all of our Jovian planets have rings. So we're going to see that in all of our Jovian planets here. Looking at our atmospheric composition, they all have the same 2, hydrogen and helium, though our Uranus and Neptune have this methane component too. And we can see that some of our total fields here vary between the planets as well. So a lot of our Jovian planets are pretty similar to another one. So Saturn and Jupiter tend to be very similar to each other. Uranus and Neptune, very similar to each other here as well. Looking at our size comparisons here, if we use Earth as a comparison here, we can see our very large gas giants here with Jupiter and Saturn, and then Neptune, Uranus have a very similar size, and then Pluto from there, our dwarf planet that we're very familiar with here as well. So just a reminder, our terrestrial planets tend to be very small in size and rocky, where our Jovian planets are very large in size, but mainly gases. So our densities here are going to be much, much lower. So just answering some of those questions from the beginning, is Jupiter a failed star? So no, Jupiter is 75 times too little mass to shine as a star. What is Jupiter's great red spot? It is a hurricane or a storm similar here that has been around for at least 300 years. Does Jupiter have any continents or oceans? The only solid matter here is going to be in its core. Is Saturn the only planet with rings? No, all of our Jovian planets here have rings. Are the rings of Saturn solid? No, so these are composed again of those ringlets, which are very, very important here. Do all moons rise and set as seen from their respective planets? No, with one exception is Pluto's moon Charon, which remains in the same place on Pluto at all times because of that synchronous orbit. So again, looking at some size comparisons here, Jupiter being our largest planet, Saturn is next in line, Uranus and Neptune are pretty similar in size here, and looking at all of our terrestrial planets here, Earth being the largest out of our terrestrial planets, which we can see here. So we defined Pluto as a dwarf planet now. So dwarf planets are much smaller in size, and some examples of this is Ceres, Pluto, and Eris. So we can see some of these different discoveries of these dwarf planets here. We also have a few suspected dwarf planets here as well. So taking a look at some of these, we can see that these dwarf planets are very, very small in comparison to Earth. Some are even oblong shape, like this one right here. So not all planets or dwarf planets are going to be perfectly round or anything like that. So another important thing that we're going to point out here are our giant moons. So a moon is any natural satellite orbiting a planet or dwarf planet. So some of our giant moons that we talked about here is our moon or Luna. Jupiter has quite a few, so Io, Europa, Ganymede, and Callisto. Saturn has Titan, and Neptune has Triton. So these are going to be some important moons here that I would like you to take note of. There's also many, many smaller moons, both rock and icy, found around some of these planets. For sure, our Jovian planets have multiple moons with them. And it's important to note here, too, that Mercury and Venus are the only planets that have no moons at all. So taking a look at some of these giant moons here, we can see our size ranges from largest to smallest. We have some of Jupiter's moons, our moon, of course, Titan and Triton here as well. Okay, so again, looking at some size comparisons here using Mercury as a size comparison and Pluto. These are some of our smaller moons compared to our large moons here. But really what I want you to focus on here is our large moons and maybe some of the specific features that we talked about throughout the notes here. Okay, so this is going to be the end of our history of astronomy and plant stuff. So we will be having our test next week on Monday and Tuesday, depending on your day. We will be taking some time to study for that test in class, but also it'll be on you to continue to work for that. Okay, we'll see you soon.